subtract 2x squared?
I'm sorry?
Subtract 2x squared.
You
Is equal to
could.
0.
You could. I'd probably do this. I'd subtract the 5x minus 4. But either way, you see, you've got a quadratic. We usually want to look at it with the quadratic expression on the left just because that's what we're used to. It's not incorrect to have it on the other side. And then you use a quadratic formula because it doesn't look like something that's likely to factor. Okay? You can factor. If you can't, use a quadratic formula, right? You always get a solution. Maybe it's complex. Maybe it's real. Maybe it's imaginary. Okay. What about 2 over x minus 5 equals 7? What's your reflex here?
Multiply both sides by x.
Yeah.
5.
Multiply both sides by x minus 5, etc. Okay? You get 2 equals 7 times x minus 5. And you go from there because the rest of that's really easy to solve. Okay, what about this? What do you do now?
Multiply by a common denominator.
Yeah. You multiply by x times x plus 6. When you do that, you get 4x plus 7 times x plus 6 equals 3x times x plus 6. Simplify it, find that it's quadratic, and you probably end up using the quadratic formula as I manipulate it, which I probably won't, so that it's factorable. Okay? Just basic equation solving that we've been talking about since January, and hopefully it's sunk in. Okay? That would be like compound interest compounded 12 times annually at 2.3%. So you invest $1,000, 2.3%, how long does it take to get $9,000? It'll take a while. You might not live that long. Okay? How do you solve the equation, though? That's a question. Didn't ask you to interpret it, but I just thought I'd mention what it means, or what it could mean. So what do you do? Well, I divide both sides by 1,000. Make that 0.024. Clear what I did? At least how I got the 9 and didn't have anything over here. And then 0.024 divided by 12 is just 0.002. So log base 1.002 of 9 equals 12t. Sure you know how to do that. Almost guaranteed that you'll see it. Okay, now this is kind of on homework. E to the kx equals 2 to the x. What do you do here? Well, we actually did it last time. I think it was last time. I'll just write it down. You get from here to here, I used the property logs. You got to remember these properties. You did well with them when I assigned them. So you just have to review them and be sure you're in as good a shape as you were on that homework, okay? But the natural log of 2 to the x is x times the natural log of 2. That's just one of your rules. Okay? There are other ways you could get from here to there, but that's where you're going to get. Okay. Log 2 of x plus log base 2 of x plus 3 equals 5. Okay? What do? Well, you use your rules for logarithms. You get log base 2 of x times x plus 3 equals 5. So x times x plus 3 equals 2 to the 5th. So you got x squared plus 3x equals 16. It's quadratic, and you solve it as such. Okay? And the last one is like 2 to the x squared plus 5x plus 6 equals 4. Okay? Which means x squared plus 5x plus 6 equals log base 2 of 4. Now log base 2 of 4 is 2, since 2 squared is 4. That means you could use your calculator if you had to. This gives you x squared plus 5x plus 6 equals 2. So x squared plus 5x plus 4 equals 2. This one you can actually factor, but if you don't see it, you could use a quadratic formula. Oops, no. Plus 4 equals 0, yeah, I'm right. X plus 4 times x plus 1 equals 0. X equals negative 4, or x equals negative 1. Quadratic formula would give you the same thing. So that's a quick 7-minute, that's almost 8 minutes, 8 minutes now. Quick 8-minute synopsis of equation solving. Everything should be familiar. Some of it might be a little rusty. Just make sure it isn't rusty when you come in for the exam, right?